problem. From the top of a 200-foot building, John observes a car moving towards him. If the angle of depression of the car changes from 15 degrees to 50 degrees during the observation, how far has the car traveled?
And this is how you're going to set up your diagram.
Yeah, so if you ever find yourself
on top of a building, you're just wondering how. Alright, turn that around. Okay, so
you're drawing a building, as you can see.
Gotta have the details.
Yeah, Timmy's a very good artist, as you can see. And he also smells, because he just came from basketball.
It's okay, though. Here's John. And you want to draw triangles. Let's draw the cars first, actually, sorry. These are the oncoming cars toward John. Stop laughing, you make me nervous.
And notice the angle starts from his eyes, not from his feet, because
he's looking
downward
with his eyes. So you want to draw two triangles because trigonometry has to do with triangles. Stop laughing, that's a fact. These are both 200 feet. It's the same as a building. Here's your right angle. This angle is 15 degrees, and this angle is 50 degrees. And we're looking for the distances that the car has traveled. So we'll name D1, and then you want to get the total distance, so you're going to minus it by the second one. I'm going to zoom in on that.
I've just zoomed in.
Okay. Oh, okay.
Okay then.
Now, go ahead and take over.
Oh.
Go ahead. Do the. Don't fall. Okay.
Now.
Right here. Write that down too.
To remind you of to remember the
acronym.
No, what's that? What is this called?
SOHCAHTOA.
I know, but like.
Okay, well, when you deal with triangles, you need to have to know SOHCAHTOA, which is your sine, your cosine, and your tangent functions.
So.
H.
Opposite over. Hypotenuse.
TOA.
Tangent. Opposite over adjacent.
Good job.
There's your SOHCAHTOA.
Now, for this problem, since you have the angles and you have an adjacent side of this triangle right here, you want to take
the 15 degrees.
You want to use the 15 degrees and the 200. So if you have the angle, so we're going to put tangent of 15 is equal to
200
opposite 200, and then adjacent would be
x
d1.
Oh, okay.
Because we use d1
over d1. Do you see that? Can you zoom on to that, Mr. Timmy, sir?
Sorry. This is really hard. Now, you're going to want to multiply both sides by d1, which is essentially just a variable. So tan of 15.
Okay, tan of 15 times d1
is equal to
200.
Now you're going to divide both sides by tan of 15 to isolate d1.
So you get d1 equals 200 over tan 15. And
now,
that gives you...
Now you get your handy calculator, and you do 200, you definitely can't even see this because of the 200 divided by the tangent of 15 equal to 746
feet, approximately. So D1
should be in degrees or radians. Should be in degrees.
Should be in degrees.
second of the two triangles, we're gonna do tangent. We're gonna do the same thing, but we're gonna do tangent. Oh, this pen is hard to write with. Tangent of 50 is equal to again. Oh yeah, is equal to 200. But this time we're gonna do D2 because we want the area in between the two.
No, you want this area.
Yeah, well, because we're gonna subtract it. Andrew, just be quiet. Gosh. And then we're gonna times both sides by D2, so we're gonna get tan of 50 times D2 is equal to 200. Tan divide by tan of 50. Tan of 50. Get your calculator out. 200 divided by tangent of 50 is equal to 100. D2 is equal to 167.8. Rounded.
Feet.
Excuse me. Now, you're going to take your information from both times, since we have D1 minus D2 here, to find the area, to find the amount of feet the car traveled. We're going to take 746.4, subtract that with 170.8, and that comes out to 746.4 minus 167.8. That comes out to 578.6 feet. So now you've determined how far the cars have traveled while John was looking at them as they were oncoming. So if you ever find yourself on top of a building and you need to do this real quick, just remember this lesson. Just remember Dr. Ang.
Is the best.
Just remember that we love you, Dr. Ang.
Is the best.
Just remember Sokotoa.